Good morning, class. Yesterday we talked about converting rectangular to polar coordinates and vice versa. Rectangular coordinates to polar coordinates and vice versa. Today we're going to be going over actual equations, not just coordinates, but equations. And you need to use what you learned yesterday in order to work today. So let's look at both example 4 in the book, page 555. I'm going to do A and B. When you look at A, it seems kind of complex, but the benefit is that anytime you see an equation that looks like this, a circle, because it's y squared and x squared, you're going to work in the exact same manner. The only thing that might change are the presence or absence of different numbers, and that's it pretty much. But the exact same process always applies. So you don't have to freak out. Anytime you see a circle, just do this exact same process and you won't have a problem. Now, yesterday, if you remember correctly, we remember that x is the same thing as r cosine theta, and y is the same thing as r sine theta. We saw that yesterday. Is this not an x, and is this not a y? So again, I'm turning it from rectangular to polar. So let's start working. My x turns into r cosine theta minus 4 squared plus r sine theta squared equals 16. That's step 1. Substitute. That's simple. Step 2, you're always going to expand the binomial. You either multiply this by itself, or you learn the rule I've been going over these past 2 years with you guys. You should know it already. A squared plus 2ab plus b squared. You can either figure that out or just multiply by itself. Once you expand this binomial, it turns into r squared cosine theta squared, cosine squared theta minus 8 r cosine plus 16. That's the expansion of the binomial. And now I'm just going to square the r and the sine for this part here, for this term, plus r squared sine squared theta equals 16. That was step 2, expanding the binomial. This turns into these 3 terms, and then just getting rid of my parentheses here. Now what am I going to do? I'm going to get rid of this 16, minus 16, minus 16. You're always going to, if there's a constant, you're always going to send it to the other side, always. So again, this turns into r squared cosine squared theta minus 8 r cosine plus r squared sine squared theta equals 0. All I did was subtract the 16. I am also going to send the identity, just the identity that's by itself that isn't squared. I'm always going to send it to the other side. You need to get rid of it, and you'll see why shortly. So whatever's here, I'm just going to leave my cosine squares and my sine squares. That's all I want on this side. Anything that isn't sine squared or cosine squared gets sent to the other side. So I'm left with r squared cosine squared theta plus r squared sine squared theta equals, I send the 8 this way by adding, right, 8r cosine theta. I'm going to need a little bit more room. I apologize. We have to adapt to the situation, and I have an awesome but very small board. So once I have this polynomial, now I'm going to start working up here. Notice that I have something in common on the left-hand side. I have an r squared in common. You will always end up with an r squared in common. That's, again, the only thing that will change are the numbers, the value of the numbers. You're always going to end up with the exact same process. So I'm going to take my common factor of the left-hand side, and I'm left with this expression. And for the people who've already caught on, they know that this is a particular identity, a Pythagorean identity, that is equal to 1. That's why it's important to get rid of everything that isn't cosine squared or sine squared. Because now, since this is equal to 1, because it's a Pythagorean identity, I can get rid of it. What is r squared times 1? R squared equals 8r cosine theta. I forgot my theta here. And now all I have to do is divide both sides by r to simplify. And I'm left with r equals 8 cosine theta. Notice this equation, which is polar, distance and angle, is the exact same as this equation, which is rectangular, x's and y's. All I did was convert it. You might have to watch the video 1 or 2 times, that's fine, but it's always going to be the exact same process, okay? Turn your x's and your y's into r cosine, r sine, expand binomial, isolate, common factor, simplify, done. That's the process. It's always going to be the same. When you're given this format, an x squared and y squared, okay? Again, you'll be given different formats, but overall, it's a similar process. Now let's look at the second example. Let's say I'm given a parabola. Y equals x squared. This one's slightly trickier, but again, the advantage is exact same process. Every time you see a parabola, just do this. Change the numbers if needed, done. You're going to change your y for r sine theta. As usual, you're going to change your x for, you guessed it, r cosine theta squared. All I did was change my y's and x's for sine theta, cosine theta. Step 2, distribute the square. So I'm going to have r sine theta equals r squared cosine squared theta. Now this is the tricky part. This is where the students who don't know what they're doing just stop working. They don't know how to proceed. Because some of them try to simplify an entire side and it just doesn't work that way. Now the trick is get rid, what you want to end up with is you only want to end up with a single r on one side and everything else on the other side. So in order to do this, if I divide this right-hand side, the side that's squared, I'm going to get rid of one r on this side and everything else that's on that side. So again, you always pick the side that's squared. This one isn't squared, so don't do it here. This side is squared, so you get rid of one r and everything else that's on that side. And since it's an equality, I'm going to divide the left-hand side by this exact same expression. Notice that everything simplifies, and on my right-hand side, I'm only left with an r. That's awesome. That's what I want. On the left-hand side, this r gets rid of this r, and I'm left with sine theta divided by cosine theta. I'm not done yet. I want to simplify. That's a cosine squared theta. So what do I do now? I rewrite it and I try to simplify. Again, as we saw last time, you can break the denominator into two parts. I'm going to put sine theta over cosine theta. That's one part, and the other part is 1 over cosine theta. If I multiply these two, I end up with cosine squared, and sine times 1 is sine theta. Again, mathematically, this is not incorrect. That's perfectly right, but I want to simplify as much as possible. If I were to be told, leave it expressed as as sine and cosine, that would be great. That you're done. But since this one's squared, you're not done yet when you're trying to just simplify. Now, from what we've seen before, what is sine over cosine? Tangent theta. And what is the inverse of cosine? Secant theta equals r. And you're done. I went from a rectangular to a polar with my r's and thetas, and this polar equation represents a parabolic equation, the exact same thing. Again, it's always going to be the exact same process. Substitute your y's and your x's, distribute the square, find the side that is squared, get rid of everything except an r, and divide the other side by what you divided that side by. Break up the terms if needed and simplify, and you're done. Now, one thing to keep in mind, going from rectangular to polar is more difficult than going from polar to rectangular, as we'll see now. So that's it for going from rectangular to polar. Now, I'm going to go over example 5. And notice in example 5, I'm given A, B, and C. Let's go over every single one. That's A. This is B. And C is the following. R equals -5 sine theta. Again, let's go over each and every single one. This is a polar equation, but I'm only given an angle and not a distance. That's fine. That's fine. This is a polar equation. I'm given a distance, but no angle. That's fine as well. This is a polar equation. I'm given distance and angle. Perfect. That looks like a normal polar equation. And again, I want to end up with rectangular equation, so x's and y's. Now, the first one is actually the easiest one, but for some reason, students freak out. And it's the easiest one. There's no math involved. Just look at the unit circle and you're done. Well, look at the unit circle and isolate and you're done. That's simple. And yet students freak out. So let's look at this example. Whenever you're given an angle but no distance, always multiply both sides by tangent. Or, find the tangent of both sides. ¿Por qué? Because that's how it works. And since I find the tangent of one side, I have to find the tangent of the other side. Now, if you look at the unit circle, tangent of pi over 6 is the same thing as square root of 3 over 3. I'm done on the right-hand side. And on the left-hand side, remember, I want to end up with x's and y's. So how do I express tangent as x's and y's? Remember, tangent is the same thing as sine over cosine. Sine is the same thing as y. Cosine is the same thing as x. So tangent becomes y over x. All that is left to do is isolate my x. I multiply this side by x, multiply this side by x, and I end up with this. Again, I turn this polar coordinate, angle, into a equation. I turn this polar equation into a rectangular equation. Y equals square root of 3 over 3x. And that's it. Every time you're given an angle, doesn't matter what's on the right-hand side, you're always going to follow the exact same process. Tangent, tangent, look at the unit circle for this value, substitute this expression for the value in the unit circle, turn tangent into y over x, isolate x, boom, 100%. Excellent job. Feel good about yourself and pat yourself in the back. That takes care of just the angle. Now, let's see what happens when they only give me a distance. Again, it's incredibly simple, and it's the exact same process. All that's going to change is the numbers. That's it. Or they might make your life easier and give you r squared. That's even better. But normally they're going to give it like this. So what happens is when they give you just a direction, what you do is, since this is an equality and I can do it if I want, I'm going to square both sides. I squared this and I squared this. That's step one. If you're given r, you square it, make it r squared. Again, and this is what's important. And this is what's important. You're not multiplying both sides by r. Because if you were to do that, I would end up with r squared on this side. But on the right-hand side, I would have 7r. That's not what I want. I want to square both sides. So I end up with r squared and 7 squared. So 7 squared turns into 49. And if you, I always say this, remember from the previous classes, r squared is the exact same thing as what? X squared plus y squared. Remember, it's like a Pythagorean theorem. R squared, the distance from the pole to the polar coordinate, the distance is the exact same thing as the hypotenuse of a right triangle inscribed within that circle. So distance is the same thing as hypotenuse. So a squared equals b squared plus c squared. So again, r squared turns into this. And you're done. That's simple. Done. Finito. If you want to isolate, you send your x and then square root. You might end up with this. And that's perfectly fine. But you can just leave it like that. Again, I went from a polar, a distance, to a rectangular, x's and y's. Done. Not that difficult. Now let's look at the last case, which again is quite simple. The only thing you guys have to really watch for is going from rectangular to polar. There's binomial expansion. There's a couple of other tricky processes, like in the second example, that you have to divide by almost everything on one side. But this is pretty straightforward. Let's go over this side. R equals minus 5 sine theta. Let me just confirm. Okay, yeah, that's it. Perfect. So here's the clue. Anytime you're given an r and a sine r on one side and a sine on the other, notice two things. There is no way to go from an r to x's and y's. And there's also no way to go from sine to x's and y's. I need r squared to go to x's and y's, and I need r sine theta to go to x's and y's. So even though in the previous example I squared both, in this example I have to multiply by r. So if I multiply this side by r, now I end up with r squared. And here I have negative 5 r sine theta. Substitute this for x squared plus y squared, as we saw in the previous example. And then you're going to substitute r sine theta for what? Y. And you're done. You can isolate, sending the negative 5y to the left-hand side. And that's it. I went from polar to rectangular. And again, exact same process. You're always going to be given r equals something, something, something. Multiply both sides by r, solve it. Sometimes you'll have a y, sometimes you'll have an x. So again, the letters might change and the letters and numbers might change a bit. The identities might change a bit, but it's the exact same flow, the exact same process. So make sure you practice. Now for homework, I need you guys to do the following. I want you to do 27, 29, 30, 31, so it's 27, 29, 30, and 31. And also, I want you guys to do 36, 37, and 38. One of each. 36, 37, 38. These are one of each of the examples we just went over, and these are the rectangular to polar. I need you guys to practice these more because they're slightly tricky. that's it for today. I want to congratulate you guys. Everyone except one person sent their homework and everyone's been checking in. So keep doing a good job. The quarter closes today. This homework is part of the third quarter. We have until next Friday to upload grades. I'll be uploading most of the grades by Monday or Tuesday. You can review your grade, and then, if you have any problems, we can talk. But remember, not everybody gave me their PBL project. Interesting. So take care, and attendance and homework. Have a great day.